Hi students, today we will talk about the application or the use of binomial distribution as proportions or to estimate proportions. So when we use the word estimate, we focus on constructing 1 minus alpha percent confidence interval. So before proceeding to deriving formula for 1 minus alpha percent confidence interval based upon proportion, we need to first talk about the application of proportion. So, whenever we are interested in seeking qualitative answers in response to any particular question, for instance, if we would like to know what is the percentage of people who agree to something or who disagree to something, what are the proportion of answers that are true or false. So, when we consider binomial distribution or application of binomial distribution, the first thing that we know is the classification of the outcome into two categories. One we call success, another we call failure. Another important feature or characteristic of binomial distribution is the outcomes of all trials are independent of each other. And in all the outcomes, the probability of success or failure remains constant. So, whenever we state the behavior of random variable x when it follows normal distribution, this is how we write it down. X follows normal distribution with mean mu and variance sigma square. We all know that the values of the location, that is mean, and scale, that is variance, in case of binomial distribution have some values. In case of binomial distribution, we know as the parameters of binomial distribution are n and p. So its mean and variance both are defined in terms of these two parameters. So we know in advance, we all know that mu or mean of the binomial distribution is n times p, whereas variance of binomial distribution is equal to npq. Substituting in places of mu, we can assume that our binomial random variable also follow normal distribution if we get this mu replaced with np and this sigma square replaced with n, p, and q. So this is how we can synchronize the distribution of random variable x if it follows normal distribution and if it follows binomial distribution. Now what is proportion in fact? This random variable we can define as p is equal to x on n. Since I have used upper cases over here, so this is representing population representation. Uppercase of x is representing the subject of interest in the population divided by the total number of subjects in the population. So its corresponding sample statistic we indicate as p hat or p cap. That should be represented as lowercase of x divided by lowercase of x. So what lowercase of x is in the sample, that may be representing the number of individuals who agree to something divided by the total number of individuals in the sample. Now we know that this is the mean value of random variable x, and this is the variance value of random variable x when it is distributed normally with binomial parameters. Now we take this and we first try to find out the mean of this random variable p hat or p cap using the description provided for x. So we apply for the mean expected value operator on the sides of the equation. Now over here on the right hand side, x is a variable whereas n is a constant quantity. So the constant quantity comes outside this parenthesis as it is in the divisor, and this expected value operator will be applied on random variable x. In the next step, we know that the mean value of random variable x that we defined in terms of binomial parameters is n times phi. This n will be cancelled out, and this is how we get it equal to p. So expected value of p hat is equal to p. What is p hat? Sample statistic. What is p? Corresponding population parameter. So we say, or we can say that expected value of p cap is equal to the corresponding population parameter p. Now we will apply in the same way the variance operator to get the approximation value for the variance. So variance of p cap is equal to variance of x divided by n. Again, random variable is x, whereas n is a constant quantity. But since variance is an operator which is quadratic in nature, when it will be applied to the divisor factor of n, this n will become squared. So variance of x divided by n square we must be getting. Now in place of variance of x, we will substitute the approximated value of variance of x, which is stated as npq. So n will be cancelled out with this n, and we will be left with pq on n. If we want to determine standard error of this variable, so we need to take square root of both the sides, and this is how we get this answer. We have now got two results. Expected value of p cap is equal to p, whereas sigma of p cap is equal to square root of pq divided by n. Now what we do, we know that z distribution we have defined in this way when our random variable is x bar, and we have substituted later on the value of this and this. Or alternatively, we can also define the same distribution as expected value of x bar, because what is mean is the expected value of that random variable what we deal with, and this is either square root of variance of x bar or standard error of, of the random variable. Now if you would like to synchronize this with our variable. Right now we are dealing with sample proportion. So if we define our random variable as p cap, so we should be indicating over here expected value of p cap and sigma of p cap. And what we have done, we have already defined or derived the results for expected value of p cap and the sigma of p cap. So we can immediately substitute these results here. Z equals p cap minus p divided by square root of p q divided by n. So this is how we have derived the z as a sampling distribution for random variable p cap that can be used either to estimate p cap, either to estimate p with the help of p cap, or we can also perform hypothesis testing on the basis of this distribution. Now we will first go for defining a formula or deriving the formula for P, which is the population proportion, and we can recall when we got this formula z equals x bar minus mu divided by sigma divided by root n. We have transformed this formula to estimate population mean mu, and we are calling it 1 minus alpha percent formula for 1 minus alpha percent Ci for the population mean mu. Now, how can we derive this formula directly? It's a very easy procedure that we need to follow. To indicate both lower and upper bounds of z, we need to mention over here both plus and minus signs and z alpha by 2. Rather, this should be indicated in terms of absolute values, but I am doing it directly. Now, what we need to do, how do we directly structure the formula for Ci for population mean mu? We keep population mean mu in the center. Then what we start our formula with the corresponding population parameter on both the sides. So that's x bar and x bar. Then what we do, on the lower bound we write down minus, on the upper bound we write down plus, and then we multiply these two factors together. That is z alpha by 2 sigma divided by root n and z alpha by 2 sigma divided by root n. This is how we have constructed the formula for Ci, and this is the direct way of constructing the formula. Now similarly, taking this formula for sample or z distribution as the p cap random variable of z as a sampling distribution for sample proportion, rather we can call it. Now again, what I'm going to do, I will indicate plus and minus sign on both sides on with z, and then subscript of alpha by 2. And now this is the population proportion that we would like to estimate, so we need to keep it in the center. And we start our formula with p cap on both the sides, definitely, of the inequality. Now we can write down, specify, mention minus sign on the lower bound and plus sign on the upper bound, z alpha by 2, and then the denominator factor we need to multiply it with, which is standard error of the random variable. Similarly over here, same thing. Now this formula is partly structured. it is not completely structured, because if you look at what we are going to estimate, in the center is P, and in the standard error factor, it is still PQ that is mentioned. Note over here that Q is equal to 1 minus P. Similarly, Q cap is equal to 1 minus P cap. That is a relationship between success or probability of success and probability of failure in binomial distribution. Now, what we need to do, it is a case same as or similar to the one when we are not given population standard deviation sigma, then we use standard deviation of sample in its place. So same thing we will do over here, since we have no information about population proportion. In fact, we are estimating it, because in the center it is mentioned as an unknown for which we are going to determine limits within which it may fall. So standard error term contains the same value. So what we will be doing in the next step, we will get it replaced with p hat, that is the p value we borrow again from the sample using corresponding sample statistic. So these two terms immediately should be replaced with p cap, p with p cap, and q with q cap. So this is how we can do or derive the formula. And this formula would help us to estimate 1 minus alpha percent. CI confidence interval for population proportion P. Now, how to use this formula and when to use this formula? I am going to give you an example. Let's suppose we are interested in determining the minimum percentage of people and maximum percentage of people that are living or earning an income below, let's suppose, 30,000 rupees a month. So in today's era of rising inflation, or rather rapidly rising inflation, it is very difficult for a lot of people, a lot of families who are earning very low income to make both ends meet. So what we need to do, let's suppose we have determined or inquired about the income of 500 families living around the city in different areas, to determine that how many of them are earning less than or equal to 30,000. So our criterion is X is representing over here the number of families earning less than 30K. So it is definitely very difficult for them to make both ends meet. And let's suppose that when we have counted the numbers in the sample, we have found that according to our data finding or results, X has the value 275. So what we do, we first estimate the sample proportion, that is 275 divided by 500 gives us a value for sample proportion. That's 55% or 0.55. If we would like to determine the value of q cap that we are going to use in the formula, this would be 1 minus p cap or 1 minus 0.55. That would give you 0.45 as your answer. Now we write down the formula. The formula to estimate population proportion is p cap minus z alpha by 2 is square root of p cap q cap divided by n p cap plus z alpha by 2 p cap q cap divided by n. So this is the formula that we are going to use to determine population proportion, a percentage of in families in the entire population that are earning less than 30,000 rupees a month. Now, students, you must ask that what is the percentage of CI? So I'm going to first write down the table in terms of Z values for corresponding CI percentages. So if you would like to construct 80%, then our Z value should be 1.282. If we are going to construct 90% CI, then 1.645 is the Z value. If we are going to construct 95%, that's 1.96. For 98%, it is 2.326. And for 99%, that's 2.575, 576. So you can take these values located from the T table. In the end of T table, you can find a small table we did discuss in the class. Over there, we are given 5 commonly used percentage of CI and their corresponding Z values. Otherwise, we did find out from the table using approximation rule. That's 1.28 here. This is 1.645 exactly. This is 1.96. This is 2.325. We have in fact determined on the basis of average, and 2.575 on the basis of average again. So whatever value you can use, it makes only the slight difference in your answer. Now let's suppose we are asked to construct 95% CI, and now I'm going to use this formula in a shortcut way, that is p cap plus minus z alpha by 2 p cap q cap divided by n. Now I'm going to substitute the values we have determined over here already. P cap is 0.55 plus and minus. For 95% CI, we substitute it as 1.96. Then we have to substitute 0.55 in place of P cap and 0.45 in place of Q cap, and divided by 500 is the sample size. Now we are going to compute first the margin of error in estimation, that is the factor that we are adding and subtracting to get the lower and upper bounds for this CI. So inside the square root, 0.55 times 0.45 divided by 500 gives us 0.022. When we multiply this by 100, 1.96, sorry, that is a z value, we get it as 0.0436. So this entire component has an answer. This entire component has an answer of 0.0436 that we can round it off to 0.044. So we subtract 0.044 to get the lower bound, and also we add 0.044 to get the upper bound. And the answers are 0.55, take away 0.044 gives us 0.506. And then 0.55 plus 0.044 gives us 0.594. If we would like to write down these numbers or answers in percentage terms, so that is making 50.6% and 59.4%. So if we want to generalize our opinion about the entire population, we can comfortably say, or conveniently say this thing, that the lower bound percentage is exceeding 50.6%. It does indicate that majority of the population is facing the problem or earning less than 30,000 and facing the problem of managing their households in a very difficult way. Now, we can interpret this answer as we can be 95% confident that the percentage of households or earnings who are earning less than 30,000 rupees a month lies between 50.6 and 59.4%, or at least greater than or exceeding 50.6 and less than 59.4%. So this is a large percentage of those families. It is representing that they find difficulties in these times according to this data, what I have taken as an example. So this is how we can estimate population proportion using a specific percentage of confidence level that we are given. You can recall when we had dealt with mean and estimated mean using CI, we have used the concepts of margin of error in estimation, and we have also worked with the sample size to determine the sample size to reduce the margin of error. So I'm going to write down the formula for the margin of error in estimation. Now E we have determined already, then there is no need. So we can just code this answer as, or interpret this answer as, plus minus 0.044. What it is indicating, we have estimated the percentage of families who are earning less than 30,000 rupees a month. So we can interpret this answer as the estimated percentage of the families who are living in the city and who are earning less than 30,000 rupees a month lies within 4.4% of the actual. We have interpreted this answer in the same way as we have interpreted the answer for margin of error in estimation in case of population mean. Over there, we have used the word mean income or mean earning. Over here, we are using the words percentage of families, because over here the scope of using proportion is to determine percentage. So this is how we can interpret it. Again, I am going to interpret again. The estimated percentage of the families who are earning less than 30,000 rupees a month lies within 4.4% of the actual. What if we would like to get this margin of error reduced to 1% from 4.4%? So obviously we need to increase the sample size. And for this reason, what I'm doing, I'm going to first determine the formula or derive the formula to determine sample size. And for this, we need to square both the sides. Squaring both the sides in this equation, we get e square on the left hand side and here we get so plus minus sign will be removed directly and we get z square alpha by 2, and this entire factor will be free from square root now. And then finally we can rewrite it down as n equals, because this can be moved over there and this should be moved to the right hand side. So this is how we get the formula to determine the sample size. Now what I have given you as an option is, what if we would like to reduce the margin of error to plus minus 0.01 from 4.4. So we'll substitute the value, and again let's suppose that we are doing it at 95% CI. And one more thing that we need to be given in advance, that what is the proportion that we expect in the population. So there are three different scenarios. Either we use the same percentage that we have determined on the basis of previous sample, that is sample size of 500. We have determined that 55% or 0.55 was the proportion we are given over it. So if we are not given any new information in the question, we can take the same value of 0.55 as the basis to determine the new sample for the margin of error reduced to 0.01. Second situation is, you may be given a new value of p cap. Third thing is, you may be given these words in the question that without making a guess. If we are given without making a guess words in the question, then the requirement in this case is p cap should be taken equal to q cap equal to zero point 0.5. So let's assume that we are given this condition. So we are going to substitute the values in the formula. 1.96 squared, 0.55, 0.5 times 0.5 and divided by plus minus 0.01. Over here you can take notice of one thing, that I am substituting the margin of error with plus and minus sign, but it won't be making difference in the answer because it is e square that is mentioned in the formula. Now we are going to determine the sample size. The value and the answer is 1.96 to be multiplied by zero point 0.5 and then again 0.5 Then we divide this by 0.01 squared. Okay, so this is how we get our answer. So you can try to determine the answer, and then do remember this, that if we will get our answer, that is usually the case, if we get our answer in decimal numbers for the sample size, we need to strictly round it off to the next number. But over here, we are getting fortunately the answer with perfect number, that is 4,900. 1 minute, let me check again. No, this is 9604. Okay, that's 9604 is the answer. So this is how we determine the sample size. And I'm reviewing what we have done in this session. We have first introduced the concept, discussed the concept of proportions, their application, the derivation of expected value p cap and variance of p cap. Then we have structured the formula of z as a sampling distribution for proportion. Then we have constructed, determined, derived the formula for 1 minus alpha percent Ci for the population proportion, and we have applied that formula on a given example. Okay, that's all for this session.